Hello, welcome again. We are covering the topic centrifugal compressor for civil structure main IFS and Gate Aerospace exam. The next topic in the main topic of compressor centrifugal compressor is compressibility effect. So the compressibility effect comes into the picture when there is a Mach number, or we can say relative Mach number, which is more than 1, because when Mach number is more than 1, then there is a possibility of shock, and after shock or approach shock there is a sudden loss of stagnation pressure. And the purpose of the compressor is to increase the pressure, but if the shock occurs, then there is sudden loss of stagnation pressure, so that is not desirable, and that should be avoided. And this now in this the Mach number should be considered on the basis of relative velocity, not based on the actual velocity, to avoid this shock phenomena. Okay, so the main point here in this topic are: first point, it is well known that the breakdown of flow and excessive pressure loss can be occurred if the velocity of a compressible fluid relative to the surface, velocity of a compressible fluid relative to the surface, means relative velocity over which it is moving, which is the speed of the sound in the fluid, because Mach number then will reach 1 or more than 1, then there is possibility of shock. Second point, this is the most important phenomenon in the diffusion process, where there is always a tendency for flow to break down away from the boundary even at low speed. So even if the impeller is running at low speed, even then we can have a relative velocity which is creating Mach number more than 1. Okay, so which can cause shock. So that should be avoided. So this is generally occurred when we want the maximum mass flow rate in the compressor for a aircraft gas turbine. Okay, so this is the general phenomenon when the maximum possible mass flow rate is required, and for that speed of the air has to be increased. Okay, so that the Mach number can exceed more than 1, and then the shock can occur. So this should be avoided. So when an effort is made to obtain the maximum possible mass flow from the smallest possible compressor, as is done most particularly in the design of aircraft gas turbine, the air speeds are very high. It is of utmost importance that the Mach number at certain points in the flow do not exceed the value beyond the losses increase rapidly due to formation of shock. So relative Mach number should be less than 1. Next point, the critical Mach number is usually less than unity when calculated on the basis of the mean velocity of fluid relative to the boundary, because the actual relative velocity near the surface of a curved boundary may be in excess of mean velocity, because however the mean velocity can provide a Mach number which is less than 1, but the relative velocity is the main criteria here for calculating Mach number. Okay, so if the Mach number should be usually less than 1, the critical Mach number is usually less than 1, because on the surface it can make Mach number more than 1, okay, which can cause shock. That we have studied that if the initial Mach number is 0.9, so when it reaches on a surface, it can be more than 1 or 1.2 or 1.3, so which can cause shock. Okay, so as a general rule, unless the actual test indicates otherwise, the Mach number are restricted to 0.8. So these Mach numbers should be less than 0.8, because even if the Mach number is 1, when initial Mach number is 1, so on inside the compressor it may exceed more than 1. So as we have studied in the first chapter in the flow regime. Okay, so if the pre-steam Mach number is less than 0.8, then the Mach number will not exceed 1 within the compressor. So that is the general rule. Okay. So this is your compressibility effect. So this phenomena generally occurs within the compressor at the intake of the compressor. Okay. So this is the velocity diagram at the intake that we have studied. This is your axial velocity, which is assumed as constant, and this is the speed of the eye at the root